All right, let's walk through this in hopes that you will finally learn. Here you see two types of graphs. You have velocity versus time and position versus time. And that is the very first question that you ask yourself when you look at the graph, is how the x's are labeled. X versus t tells you how your position changes in time. Well, in this case, it does not. So if I look at 0 seconds, and if I look at 5 seconds later, let's say this is 5, and let's say this is 10 meters away from whatever this may be your home or whatever. This is just the point of reference. So you are still sitting at 0, you were at 10, and at 5 you're still at 10. So there was no change in x. So as you know, velocity is change in x, how your position changes in time, so over change in t. Now there was no change in x, this was 0, which means that my object is not moving at all, so this would be at rest. On the left, you see a similar looking graph in terms of this is also a flat line, but what is important is that it's v versus t. So that shows how velocity changes in time. And again, let's say this is 5 meters per second. This is also 5 meters per second. So your velocity did not change at all. It's a consistent motion at a constant velocity. You're not changing direction. You are not speeding up or slowing down. So the answer to this would be moving at a constant speed. Let's look at our next example. Again, we have two graphs that look very similar to each other, but the main difference again is x and v are plotted versus time. Let's look at this one. So I start over here. Let's say it's 4 meters. And in a certain time, if I look here, this would be probably about 9. So as time passes, let's say this is 0 seconds and this is 5 seconds. In the course of time, that was 5 seconds, my position changed from 9 to 4. So if I find the change in x, that will be 5 meters. Then the slope of this graph right here, rise over run, this would be 5 and this would be 5. So the slope of this graph is positive. I'm moving in the positive direction. You can call this north, which is a positive direction, or up, whatever makes sense. I have a positive velocity of the change in x was 5, so 5. The change in time was also 5, 5. So I had a velocity of 1 meter per second. And because the slope is consistent, I know that this velocity is constant. There are no curves, which means that this graph illustrates moving at a constant speed in the same direction. I can even say that it's moving at a constant velocity. Now over here, on the right, we have velocity versus time. Let's say, again, I start at 4 meters per second. And in the course of, let's say, 2 seconds, I go to 9. Change in v is present there. It's a consistent slope, so it's a constant change in v. And in my case, it's again 9 minus 4, which is 5 meters per second. So my velocity increased by 5 meters per second within 2 seconds. So then I can even find my acceleration, which will be 5 over 2, 2.5 meters per second squared. Consistent slope of v versus t in the positive again direction. My velocity is growing from 4 to 9. So my object is moving faster. It is speeding up, speeding constantly because my slope is constant. So again, this is the consistent slope. It's not curving up. So this would be moving at a constant acceleration, or with a constant acceleration, as it says here. The next one, they look the same, but we're just going to use different terms. V versus t, the slope, constant positive slope. My object is speeding up. So it's moving in the positive direction, it's speeding up, it's accelerating. Here, x versus t, consistent slope in the positive direction. So I'm moving, not speeding up, not slowing down, moving at a constant speed in a positive direction. Now let's compare these two graphs. Both of them are x versus t, and they both have positive slope. The only difference is that I started my motion below whatever this is. Let's say this is home. So I started south of home, but I'm moving north. So again, I'm moving with a positive change in position. I'm going north, so the answer to this, since it's a consistent slope, it's a consistent speed, consistent velocity, and so we're moving at a constant speed in the positive direction. So there is definitely no difference between these two graphs. So this graph and this graph are the same. The only difference is where you started your motion. These two graphs, however, are very different. I can say that this is -5 and then this is 0, obviously. So what happens with velocity, it's actually getting closer to 0. So the object is slowing down. Even though this is a positive slope, here we said that we were speeding up, here we're slowing down. There was negative velocity, so we were moving south. And we realized that we're going the wrong way, so we started slowing down, which is a good thing. If you're driving on the one-way street going in the wrong direction, you better slow down. So that's a positive thing. Anyway, what you need to notice is that your velocity is going from some kind of non-zero to 0, so you're definitely slowing down. And it's a consistent slope, so it's a constant acceleration, but you're constantly slowing down. You were going in the wrong direction, realized it, started slowing down. Moving on to the last four. First question, how are these labeled? It's x versus t. So this would be velocity. It would show us how our position changes in time. What happened with our position? We moved from somewhere up north, let's say 10 meters, and we came back to 0. So we were moving south, which means we are going in the negative direction. Change in x is -10, and then my change in t, whatever that is, I'm going to say this is 10 seconds. So then my velocity is just -1 meters per second, meaning that I'm just going in the wrong direction. The minus in front of velocity means that we're going south. It's a consistent slope, so velocity is constant, and it's just in the negative direction. So we're moving at a constant speed in the negative direction. That's the answer. Now here we have velocity versus time. What is happening with our velocity? Well, it dropped from, let's say, 15 meters per second to 0. We decelerated, we slowed down, and we slowed down at a constant rate, so we have a constant negative acceleration, which means that the answer to this is slowing down. The last ones, this is velocity versus time, this is x versus time. Velocity versus time. Velocity is actually growing. We're just moving in the wrong direction. So it was 0, and now it's -10. So my velocity changed. I actually sped up, but I sped up in the wrong direction. I'm not slowing down. So notice that these two, this graph and this graph, are similar. They both have this negative slope, but you're looking at how your velocity changes. This one changed from 15 to 0. So you are slowing down. Here, you went from 0 to something that is not 0, so you are speeding up in the negative or wrong direction. Here, your position is changing, definitely, and it's changing going south. So you are moving at a constant speed because it's a constant slope, no curves. So you are moving at a constant speed because there is no slope. You are not speeding up, you are not slowing down, you are moving at a constant speed, but not in the positive direction because you are going south. Your answer is you're moving at a constant speed in the negative direction.